So this is somewhat of a different subject than the first speaker. This is not about politics, it's more about technology. I know you're all standing here holding mobile displays in your hand or mobile phones. So this presentation is about what we call closing the mobile connectivity gap. So technology advances all the time. New technology comes in, and every technology tries to earn its place by making things better for the user. So the new technology that's coming about, referred to as nanotechnology, is a technology that has a lot of promise in being able to close the gap of the mobile connectivity. By the gap, we meant making more visual information available to mobile users everywhere. So let's explore that and see what does that mean. Can you see the next chart? So the next chart talks about what is the mobile connectivity gap. If you look at the entire network you are connected to in your mobile, you'll see that you have a mobile device in your hand that has processing power, that is able to do a lot of things. So it can easily, should be able to give you a lot of information, video, and so on and so forth. And at the same time, the networks, like the internet and the wireless networks and the Wi-Fi, can give you a lot of bandwidth to give you a lot of information. And when we go across the network, we will see mobile, content providers that are able to give you very rich content all the time. So where is the gap? The gap that we face today is the connectivity between the mobile unit and your visual system. As you can see today, you cannot see any of your phones as you're looking at it today. You're probably having a hard time seeing this display. So this entire presentation is about how we're gonna be able to close that gap. So we have all enough bandwidth across the network, but when it comes from the mobile to your eye, we have a bottleneck. What's the bottlenecks caused by? Number one, displays are just not bright enough. Number two, they don't have enough resolution. Number three, they don't have enough area. And number four, and most importantly, is that they consume too much power. So it's not gonna be any better if it stays that way for the mobile users. So the first thing we're gonna do is we're gonna tell you about something that, what is nanotechnology? Nanotechnology is a technology that will be able to create material that will combine light and electrons. Today, your phone have lots of electrons going around, connecting you to the network, and so on and so forth. When it comes down to the last trip from your phone to your eye, we have to convert these electrons to photons, or more or less to light. So optoelectronics, it's the business of changing the information from your mobile so it can get into your eye, okay? Well, is this a new technology? Well, it's somewhat new, but it's not very new. It's being applied today in mobile phones. Yes, it has. The phone you have in your hand has a backlight that is using something called LED, light emitting diodes. Probably this display here also doing the same thing. So there's a lot of introduction to nanotechnology as we speak now. Well, the thing is that how is this nanotechnology gonna evolve from what it does today, which is basically being a light source, to being a smart light, a light that will be able to couple information into your eye more efficiently. Well, in order to do that, we have to solve the biggest problem for mobile displays and for all mobile applications. If you are in the business of applying technology to mobiles, you worry about, is it small enough? Is it compact? Can I put it in my pocket? That's number one. Number two, you also worry about how much power is it gonna take? Is it gonna take away my battery? Am I gonna be able to use my phone all day or maybe all week without charging it? And number three, you worry about how much it costs. Well, actually, the guy that manufactures the phone worries about how much it costs, because if it costs too much, he will make you pay too much, you're not gonna be happy, and nobody's gonna be happy at all. Well, in all these three counts, the displays today go negative. They consume a lot of power, they don't have enough brightness, they cost too much. In fact, the mobile display has a bill of material cost. The largest cost element in a mobile display is a mobile unit you have, is the display itself. So what are we gonna do about it? So we're going to go on the next chart and explore how are we going to be able to make nanotechnology make the difference for us. The first area is an area in which a lot of people have been talking about. How can we address the size of the display? We're really limited by the 5 by 8 centimeter. I'm going to talk centimeters. If you guys don't mind, I'll explain it in inches a little later. But the 5 and 8 by 8 centimeter that you have is really not a big display. When you look at it, your peripheral vision goes all the way from here to there, and the display is very small. So the technologies are coming out with a new thing, and the new thing is that we will put a projector in your phone. So you'll be able to push a button and get an image that can be as big as 20, 30 inch. You can share information with other people. You can view it better, and so on and so forth. You can even get high definition on your phone. Imagine that. You'll be able to see high definition content on your phone. You may even evolve to have 3D coming straight. So, how are we going to, this is breaking up. That's okay, it's coming in and out. So, you know, the most important thing is that, of course, if you know what a projector look like, if you have a conference room and you see a projector, it's probably, the small one is as big as a brick. So how are we going to get it from being the size of a brick to being a size that will fit in your mobile? That's one big challenge. The other big challenge is that, well, when you look at the projector in your office, it takes 200-300 watts. So how are we going to get it to be able to consume 1 or 2 watts? That's another big challenge. And then lastly, if you ever bought a projector, you'll find out that it costs you $1. So the challenge is, again, how to be able to bring this technology down to a small size. And I believe that these challenges can be effectively addressed by nanotechnology. And by the way, just to get you to relate to what nano is, your fingernail grows 1 nanometer a second. So just you appreciate how small that is. In nanotechnology, we build devices that will have few nanometers, 2 to 5 nanometers. Those are the geometries that we can use in order to make electrons convert to photons and get to your eye, okay? So we'll go to the next chart and say, how are we going to be able to make it small? And what, you know, in order to make it small, you have to figure out what is really making it what it is today. What is making it what it is today is people are basically have a projector that's been invented for maybe the last 20 or 30 years. And in fact, maybe even for the last 100 years in the cinema. And then the notion of a projector has not evolved since cinema was introduced. There was a light source, a very powerful light source, and what we call a light modulator in front of it, the film or something like that. So that idea of a projection has been around since cinema was introduced and have not changed. And everybody running around is trying to take that cinema projector idea and compact it into a small size so it can fit in your phone. And of course, often when you do that, you basically hit the brick against what is the limitation of the technology. So there are a few people running around actually trying to do that. They're trying to squeeze all the air out of the projector, make it small enough so it fits in your phone. Of course, they're having a heck of a time. The most important of them, it's very big and it costs about $100. It's not going to get there. So what nanotechnology is going to do is basically have it start a new paradigm. Remember, every time there is a technology that makes its own economy, it is associated with a new paradigm. And the new paradigm is that don't think about it as if it is an evolution of something that existed. It has to be something new. Anything that is going to cause a revolution, it has to be a new idea. So with nanotechnology, we will be able to show you how we can put together an entire projector in a single chip. Now that's a big evolution, if it can be, from the cinema projector you're used to. So if you look at your mobile device, you'll find out it has about maybe 20 or 30 chips. So we're talking about making one of those chips being a projector. Imagine that. Or how are we going to do it? By actually integrating the light emitting material on the chip itself. So that's a new advance. And that light-emitting material will actually form the pixel that the light comes from. And that chip will have all the capability to be able to give you HD. It will be able to give you 1 million pixels in 1 square centimeter. And not enough. It's just 1 million pixel in 1 square centimeter was enough light that you can see it right where I'm standing in La Jolla, under the sunlight, with the sun above me. That would be really great. That's number one. Number two is that since it's a small chip, and since it's done in exactly the same way an Intel processor is done, it can be done in the same factories with the Intel processor is done, and it can be relatively low cost. So how cheap can it be? It will definitely can be in the 20 bucks. If it can reach the $20, then it can reach a tremendous market potential. So, today people are projecting that markets like this will have maybe in 5 years, about 50 million units can be sold. We're averaging about maybe $3 or $4 billion of total market value. But I'm a believer that if we introduce the nanotechnology projectors, projector on a chip, we can actually make this market more than quadruple, or maybe even go to even 10 times. Imagine the camera in your phone. Not long ago, the notion of having a camera in your phone was completely unknown. Today, there is 800 million cameras sold inside your phone. So I believe nanotechnology will enable you to have a projector in your phone who's sharing information and accessing information all day, and it will reach an 800 million units, massive markets. Next, so we'll ask ourselves, what else can nanotechnology do? What nanotechnology do beside the projector, it can allow you to be able to do 3D. That's very important. And it's also allow you to be able to do sunlight viewability. Those two things are almost like the holy grail for mobile. Because when you look at the people who use your phone today, the phone, you actually look at your phone and watch what's going on in your phone more than you do in your TV. So information coming at you, the only way you can see it through this little display. So the first idea is that when you look at the sunlight, if you go outside, turn your phone right now on, you can't see anything. But when you look around, in each one of those, in each square meter, which is about the size of a small dinner table, there's 1,000 watts of solar sun falling on that table. 1 kilowatt from the sun falls on the table all the time. That's enough power to run your entire kitchen appliances. So why can't we take some of that power, recycle it back, and give it back to you as a light? Of course, with the smart chip being able to make that light an actual display. This will happen. This will happen one day. You will see displays that will actually take about 4 watts come from the sun striking your cell phone front end. That 4 watts, if I recycle it and bring only 5% of it, I can give you a display that is 10,000 nets. 10,000 nets. Your TV at home is about maybe 300 or 400 nets. This is 10,000 nets. This is like 2 or 3 orders of magnitude brighter. That's very important. And the next is going to 3D. And what's the big secret about 3D? Well, number one, 3D that's circulating around you now, we don't even call it 3D because you have to have glasses. And it's more or less is not really a 3D. So what is true 3D? A true 3D is a 3D, you look at it with your naked eye. And you look and you see and you perceive 3D images. Nanotechnology can give you that by virtue of we can create pixels that are so small, 10 micron. Remember, the hair in your head is 80 micron. So we can pack 8 by 8 pixels in the cross-section of your hair. They're bright enough that when we put them next to each other, we can have enough pixels to be able to give you a 3D experience, full parallax, 360 degrees, with no glasses. Then we're talking about, closing the gap. So with all of those capabilities, this technology is new and coming. There's not a whole lot of people really working in nanotechnology, but it's up and coming. We're talking about the idea of smart light. So, and that's a brand new idea in the fact that since the light bulb was invented, it's been just providing light. But now nanotechnology and the light coming out of nanotechnology will make the light a smart light, will make the light actually carries information. So with that idea, we'll be able to give you large displays that you can project from your own phone. We'll be able to give you displays that takes very little power, in fact, no power at all if you're standing in the sun. We'll be able to give you displays that will give you 3D, and on top of that, we will think it's going to be cheap enough that will be in most mobile units around. So when you look at all of that, imagine how many units around. Every single year, there is 1.4 billion phones sold every single year. And if you think about it, you probably can put these projectors in cameras. You can put them if you add everything else, PCs and so on, that's a $3.4 billion market. So if you can create a display that will answer the call on those 3.4 billion display, you probably can create a brand new industry. So anyhow, that's my presentation. Thank you.